Alright guys, this is going to be part 2 to the shop vac troubleshooting video where I'm actually going to show you how I'm going to repair it. Now, there's a couple different ways you can do this. I'm going to do what is probably not necessarily the recommended repair. In fact, I would actually encourage you guys to just replace the thermal fuse. I'm going to do it a slightly different way just to see if it's going to work. Now, you know, that comes with its own list of caveats. Obviously, you're taking a risk doing this repair at all, especially if you change the original design, which we're going to be doing some somewhat minor but meaningful modifications to this that is going to change it to work in a way that was not originally intended. So with that obviously comes some risks. You know, this is a safety device, a safety fuse to keep you from overheating your vacuum and hopefully prevent any fires or meltdowns from occurring. We're going to be kind of changing some things around, so there's always the risk that with that change that could eliminate that safety factor, and maybe this could eventually catch on fire or burn down. You know, be aware of the risks. Don't take my word for it. Don't even do what I'm doing. I'm just making this for information and entertainment more than anything. But if you want to do it the right way, look up the part number on the fuse. Buy it on Amazon. They're $5 or $10. You know, swap it out. Do a good job on it. Make sure the connections are good. Put it back together, and Bob's your uncle. Or even better yet, you know, throw your old shop vac away and buy a new one if you have any worry or hesitation at all. I don't. I want to try this, so we're going to move forward. Now, I've already cut the old thermal fuse out. It was just in line with a coil here. You've got your one end of the coil here. I've gone ahead and cut off. The other end, where the fuse was in line with, just goes to this spade connector here. And what we're actually going to do, instead of a replacement fuse, I got a resettable thermal fuse or thermal overload circuit breaker, whatever you want to call it. Same idea. This is a 15 amp breaker. I thought this was a 15 amp fuse. It looks like it's actually a 10 amp fuse. Now, when I looked up my Amazon order history, it said I had ordered a 15 amp fuse. So now I'm a little confused as to whether this is supposed to be 10 or maybe it's supposed to be 15. Maybe that's why it failed again so soon to begin with. Nevertheless, we're going to move forward with a 15 amper. What that means is it's going to have to get a little bit hotter to fail than this did. Which may ultimately end up with this thing just melting down the next time. So again, that's a risk factor to take into account. We're going to do it anyway. So got the old fuse out. You know, basically cut it on either side of where I had it crimped before. Now, what I can do, I could solder this back together. I could probably even just eliminate this little length of wire altogether. I don't think I'm going to. I think I'm actually going to pull it all the way through here and back around, because now it's not really long enough since I cut a good almost 2 inches out of it. So we're going to pull it back around to here. Actually going to cut some of this burned wire off. And to splice this back together, I'm going to use something that, you know, I bought a box of these, haven't used any yet. I'm going to give it a shot. These are Wago connectors. I know they're a little on the controversial side. Seems like one side of the pond or one side of the world thinks these are the best things ever made. I don't know about that, but I think for this application, they'll work just fine. So what I need to check now is so that I do have continuity on my coil. So that coil's good. And that coil's back to being good. And you know, actually what I may do, originally I was gonna start my spade connector for my circuit breaker off of this. Maybe I still will. So my question is, where do I want to connect this? Do I want to put it back in between here or in between here? It really makes little to no difference. Just as long as it's in line with one of these coils. I could even put it on this side if I wanted to. What I also need to do is kind of make sure this is still going to fit inside that bell housing. Now, normally you don't want to get so crazy with a coil, a motor coil. This is a very basic motor though. And we should be okay. So this can go in back in here. Now when putting these brushes back into place, we're just going to push them out. They're under spring tension. We'll hold the brush leads carefully between our fingers. Or we could just pull them all the way out. Just be careful not to break the spring. Or to let them slam back in like I just did. All right. I'm going to turn my torque down to 1. We don't need to go super tight on this. Just a couple ugga-duggas. And everything's spinning well. Put our brushes back onto our one side of each spade. And then what I'm going to do, I'm going to ultimately wire my thermal fuse or my overload here back in line with the hot lead of my power cord. So we're going to strip a little off the end here. I'm using insulated female spade terminals. Make sure that's nice and tight. Now let's go ahead and put our motor back in place. I do want to connect this back before I screw this back together. And plug our neutral back into. All right. Put our bushing back in place. This helps keep it centered. Put our impeller back on, washer and nut. That's good. Just knock a little bit of the dust out of this. We're going to blow everything out really good at another point. This slides back in here. I'm actually going to magnetize my bit. I'll be right back. Really good little tool to have is these Klein Bit Magnetizers. You got a demagnetizer on one end, magnetizer on the other. Just run it back and forth a few times. And now we're magnetized. That thing works actually very, very well. And they're not too terribly expensive. See if I can link to one in the description for that as well. And last one for this piece. And what's nice, if you don't want it magnetized anymore, it's got a demagnetizer side. And it works probably even better than the magnetizer side, as you can see. So these things are definitely worth their weight in gold. I put one on just about all of my main tool bags, as they come in handy more than you'd think. So last screw for this. Okay, now I got to think about where this is all going to go. This is my original power cable. So we want to start putting that back in its slots. I think what I want to do is just put this in line with the switch in series. Which that switch is right here. And the switch does have a direction as far as how it's indicated on the housing on and off. So we want to make sure that's right. We'll put this back together. That's off, that's on, leave it off. And I don't want this any longer than it needs to be, so I'm gonna put it I think right here. Should have plenty of room. So just added a hole right there. That should be nice and out of the way, plenty of clearance. This is going to go to our switch. Right, so off is towards me. One. Two. And we just need a short guy. Actually, what I can do is use this guy. Since I've already got it, I'm just going to replace the spade connector. Tighten out this hole just a little. Deeper. And I seem to have misplaced my nut. So I'm gonna grab another one. Bought a 5-pack of these 15 amp resettable fuses. They do come in handy from time to time. And it was only about $2 a piece, so why not? That's going to work out just perfect. Clip this wire out of the way. Carefully assemble this back together. Sure the cord's back. There we go. This actually looks like it was made to go there, which is a happy little byproduct of doing something like this. Again, there's a little bit of risk in modifying an original design like this, but not much. I mean, worst case, may end up melting one of the coils or burning the power cord up or something, or one of the jumpers may melt, and then we can replace that, maybe go back to the original fuse. But I don't see why this should have any problem doing how we need it to do. One more screw. These little M12 Milwaukees are about the best thing ever made too. And these are about as powerful as I think the original 18 volts used to be, back when I first started using cordless tools. And of course you can turn them up, turn them down. Super lightweight, portable, and just a joy to use every time. So we're gonna see if that fixed us, and then off camera I will go ahead and clean out my filter, blow out my head unit here a little better. And put everything back together. I'd say that was a success. So that's it, guys. Hopefully that gives you some ideas. Again, do this at your own risk. Make sure you're not putting yourself in a bind if something were to fail catastrophically to the point that this would melt down or catch on fire. Understand you're voiding warranties. If it breaks again, it's probably going to be, if this doesn't work, then it'll probably melt down to the point that you'll have to buy a new one. I'm fine with it. I just thought this would be a fun little project. And it was. Hopefully you guys were able to learn a couple things, maybe even what not to do, but just kind of see how the process goes when I jump into a project and try to modify something. So I like how that looks. I like how it works. I think we're going to be just fine. So thank you guys again for watching. Any comments, questions, by all means, always feel free to leave them. And we'll see you guys on the next one.